All right, so chapter 4, section 1 deals with quadratic functions and transformations. So first we have a parabola. A parabola is the graph of a quadratic function which can be written in the form as ax squared plus bx plus c. This is the standard form. Of a parabola. And the graph of a parabola is going to look like a U. So every equation that has an x squared, the graph of that equation is going to be a parabola. So x squared means it's a parabola. In 4.1, we're going to deal with the vertex form of the parabola, which looks like a to the x minus h squared. So there's that squared that tells us it's going to be a parabola, plus k. So this is the vertex form. The axis of symmetry is a line that divides the parabola in two mirror images. The equation of the axis of symmetry is x is equal to h. So in this graph, the axis of symmetry is going to be the line right down the middle. It divides the parabola into two mirror images. So the line right down the middle is the axis of symmetry. And the vertex of the parabola is hk. It's the coordinate hk. So you'll take the h from here and the k from here, and that'll be your vertex of the parabola. So the parent function is the graph of any quadratic is a transformation of the graph of the parent function. So the parent function of a parabola is going to be y is equal to x squared. This is what your standard parabola is going to look like. And any other equation that has x squared is just going to be a transformation of this parent function. So this is the parent function graph. In this equation, do we have an h or k? No. So what do you think our vertex is going to be? What's our h? 0. And what's our k? 0. So our vertex is going to be 0, 0. Our axis of symmetry is x is equal to h. What's our h? 0. So x is equal to 0 is going to be our axis of symmetry. So the translations that are going to happen depend on what the a, the h, and the k are going to be. So the a is going to either be a compression or stretch of the graph. So a compression is just going to make the parabola fatter, and a stretch is going to make the parabola taller and skinnier. So a compression will happen when a is like a fraction. So if a is like 1/2, the graph's going to be shorter and fatter. And the stretch will happen is if it's a number like 2, 4, 3, any number greater than 1 is when the stretch will happen. When a is negative, what do you think is going to happen to the parabola? When a is negative, the parabola is going to flip and go upside down. So when a is negative, instead of being a smiley face, it's going to be a frowny face. Okay? So this is when a is negative.
What happens if it's 1?
What happens what?
If it's positive and it's 1, you just said 1/2, it gets fatter and then...
When a is 1, it'll be like the parent function. Like it'll just be the regular parabola size. So the h, which is always going to be inside the parentheses, is going to determine whether it's going to move left or right. So the number that's inside the parentheses is going to determine left or right. And the number that's outside of the parentheses, the k, will determine whether it's going to go up or down. Okay, so let's look at example 1. What is the graph of f of x is equal to 1/2 x squared? So we see that x squared, so we know it's going to be a parabola. First, let's find the vertex. We said the vertex is h comma k. Do we have an h or k here? No, so what's our vertex going to be? 0, 0. So we can plot this point on the graph at 0, 0. Next, we have our axis of symmetry. Our axis of symmetry is x is equal to k. X is equal to h. What do we say our h is? 0. So our axis of symmetry is x is equal to 0. So we're going to draw a line on x is equal to 0. So it's going to be this red vertical line. Right on the y-axis. Now we're going to plug in numbers into x and see where our parabola is going to be. So we're going to plug in x values and see what we get as our y. And then we're going to have coordinate points x, y that come out. So what's a number we can plug in for x? 2. So when we plug in 2 into this equation, what do we get? What's 2 squared? And what's 4 divided by 2? 2. So we get 2 as our y. So one of our points on this graph is going to be 2, 2. So we can go to our graph and graph that. So we go right 2 and up 2. So we'll have a point right there. We're going to have the same point on the other side of the axis of symmetry. So we'll go to the left 2 and up 2. So we'll have another point there. What happens when we plug in 4 into x? What's 4 squared? 8. What's 4 squared? 4 times 4. 16. And what's 16 times 1/2? 8. So our y value when we plug in 4 is going to be 8. So we're going to have another point at 4, 8. So we can go to our graph. We'll go to the right 4 and up 8. It'll be off the graph a little bit. And we're going to do the same thing to the other side of the axis of symmetry. So we're going to go to the left 4 and up 8. Do you think we have enough points to graph it now? Yeah, so we can just put a U through the points that we have. Okay, let's do example 2. We're going to do the same thing. So we're going to find the vertex and the axis of symmetry. And then we're going to plug in points and graph it. So our vertex is h comma k. Do we have an h or k here?
No.
So what's our vertex going to be? 0, comma 0. So we'll graph that point at 0, 0. Our axis of symmetry is x is equal to h. What do we say our h was? 0. So our axis of symmetry is x is equal to 0. So again, it's going to be a vertical line right on the y-axis. Looking at the equation that it gives us, it's negative 1/3 x squared. So automatically, what do we know about this parabola? It's going to go down. It's going to be a frowny face. So it's going to look like that. What's a number we can plug in for x? 3. So when we plug in 3, what's 3 squared? 9. And what's 9 divided by 3? So we're going to get negative 3 for y. So our first point is going to be 3 comma negative 3. And we'll go to the graph, and we go to the right 3, and then down 3. So we'll have a point there. And we need to put the point on the same side, on the opposite side of the axis of symmetry. So we're going to go to the left 3 and down 3 on the opposite side. We can also plug in 1. What's 1 squared? 1. And what's 1 times negative 1/3? We can just say negative 1/3. So what's another point we're going to have on this graph?
You said Barrett broke down the student services?
Yes.
1,
1 comma negative 1/3. So we're going to go the right one, and then we're going to go about 1/3 down. So it's going to look somewhat like that. And now that we have at least 2 points, we can draw our parabola.
That's all we need, like 2 points?
Yeah.
Like, how do you know when to plug in for x? Like,
Usually plugging in 1 is a good start. And then this one, Jonathan said 3, probably because it has a 1/3 in it, so you know that it's going to equal a whole number. A whole number is going to come out of it when you plug in 3. Like the last one, we had a 1/2 in it, so I tried to stick to even numbers that we plugged in. Okay. But usually 1 is a good number to plug in right off the bat. Okay. All right, example 3. Graph the function g of x is equal to x squared plus 3. How is it a translation of f of x is equal to x squared? So again, we're going to find the vertex. Our vertex is h comma k. So what's our h here? Remember, our h is inside the parentheses. Do we have any parentheses here? No. So our h is going to be 0. What's our k going to be? 3. Perfect. So our vertex is going to be at 0, comma 3. So we're going to go up 3 on the graph. Now our axis of symmetry is x is equal to h. What did we say our h was? 0. So x is equal to 0 is going to be our line for the axis of symmetry. So again, it's going to be a vertical line down 0.
Would it always be 0?
No, not always. When we have an h, it'll be different. But on these 3 examples, we haven't had an h yet. H has been 0. So now we can plug in numbers again. So we're going to plug in numbers for x and get a y and then get some points on our graph. So Kyler, what's a number we can plug in first? 1. So 1 squared is 1, and then what's 1 plus 3? 4. So our first point's going to be 1, comma 4. So now we're going to graph that. So we go to the right 1 and up 4. What's another point we can plug in? 2. What's 2 squared? And what's 4 plus 3? 7. So our y that we're going to get when we plug in 2 will be 7. So our point is going to be 2, comma 7. So we go to the right 2, and then up 7. And then we're going to do the same thing on the other side of the axis of symmetry. Go to the left 2 and up 7. And now we have enough points to graph it. So our parabola is going to look like that. How do you think this is a translation from the parent function, x squared? Remember, our parent function looks like this, just at 0, 0.
It just went up.
It went up how many?
3.
3, exactly. So it went up 3. Any questions so far? All right, let's go to example. We're going to do the same thing. So we start with our vertex. What's our vertex going to be?
1.
Remember, our vertex is a point, h, k.
Oh, 1, 0.
So if we go back to the vertex form, inside the parentheses, it's x minus h squared. So h, whatever it is in our equation that it gives us, we're going to flip the sign. So it gives us a positive 1 here, but we're going to flip the sign and make it a negative 1.
And if it's negative, do you flip it?
And it becomes a positive. Only because the vertex form that it gives us, h is negative in it. So since it's a minus h, we're going to flip the form of the h in the equation. So what's our k? 0. So now we can graph this point. So we go negative 1 to the left 1 and up 0. So we're going to have a point right there. Our axis of symmetry is x is equal to h. What's our h here? So x is going to equal -1. It's going to be our axis of symmetry.
So whatever the point, like, since we did -1 for the point, it's always gonna be on that point.
The vertex is always going to be on the axis of symmetry. So our axis of symmetry is going to be a line through -1. Now what do? We find points. So we're going to plug in values for x and get values for y. So what can we plug into x? 1. What do we get when we plug in 1? We get x plus 1, so 1 plus 1 is 2, and then 2 squared, 4. So when we plug in 1, we're going to get 4. So our first point is going to be 1, 4. So now we go to the graph. We go to the right 1. So we're going to the right 1 on the... So this is our y-axis. So we're going to go from 1 to the right of the y-axis, not from our axis of symmetry. Okay? So even though that's at -1, we're still going to the right 1 from the y-axis. And then we need to go up 4. So we go to the right 1 and up 2, 3, 4.
And the other point will be on the axis of symmetry.
Well, the other point, since we're 2 spaces away from the axis of symmetry, we need to be 2 spaces away from the axis of symmetry on the other side. So we're going to go 2 spaces away on the other side. So on our graph, everything's going to be perfectly symmetrical on the right side of the axis of symmetry and on the left side. So since this point is up 4 spaces and 2 spaces away from our axis of symmetry, we need to be up 4 spaces and 2 spaces away from our axis of symmetry on the left side. What's another number we can plug in?
2.
What about 0? Can we plug in 0? So what do we get when we plug in 0? When we plug in 0, what's 0 plus 1?
1.
And what's 1 squared?
1.
1. So our point's going to be 0, 1. So we're going to stay on the y-axis and go up 1. So since we're 1 space away on this side of the axis of symmetry, we need to be 1 space away on this side of the axis of symmetry. So our other point will be right there. And now we have enough points, we can graph our parabola. You can use any numbers. It doesn't matter. But like I said, I'd stick with plugging in 1 first, just because it's going to be the easiest. And then somebody said we could plug in 2. We could plug in 2, but 2 plus 1 is going to be 3, and then 3 squared is 9, which would be off the graph, which we could do that. That would work, but 0 would just be easier. So that's why I stuck with 0. Any other questions? All right, example 5. So now we need to find the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range. So what's the vertex here?
104 and -2.
Perfect. So it's going to be a positive 4 because we need to flip the sign of the h, and the h is inside the parentheses. And then the k is going to be negative 2. Awesome. Our axis of symmetry is x is equal to h. So we're going to get x is equal to 4. So now we need to find whether this graph has a maximum or minimum value. So if we graph it over here, roughly, we're going to go to the right 4 and down 2. So this is going to be our vertex. And then our axis of symmetry is going to be through 4. So our graph is going to look somewhat like this. Something like that. Not exactly. Will this graph have a maximum or minimum value? Does it have a highest point? So these arrows go up, or does it have a lowest point? Minimum. It's going to have a minimum. And what do you think our minimum is going to be? The point. So what's the lowest y value on this graph going to be? What did we say this point was at? What did you say? Negative 2. So our minimum is going to be negative 2. Now we're going to find our domain, which if we had a pencil and we were taking all of the x values from this side of the graph all the way to this side of the graph, these arrows mean that this parabola is extending forever in that direction. So it's going to have a point no matter what x value we're at. So what do you think the domain is going to be? All real numbers. Yes. And then the range, we're going to look at the y values. So we're going to start at the bottom. We don't hit any graph until we get to negative 2. So what's the first value of our range going to be? Negative 2. And what do you think our second value of the range is going to be? We keep going up. The graph will keep going forever upwards. So 2 to infinity.
Just draw it.
All right, so one more example. What are the vertex and axis of symmetry, minimum or maximum, and domain and range of the function? So let's find our vertex. What's our vertex going to be here? Negative 1, comma 4. Mia, what's our axis of symmetry? Remember, axis of symmetry is x is equal to h. So what did we say our h was? Negative 1. So our h is inside the parentheses, and we have to flip the sign. So it becomes negative 1. So if we graph this, we're going to have a point negative 1, 4. So point up here. And our axis of symmetry is going to be through negative 1. So how do we know what this parabola is going to look like? Is it going to be up or down? Down. Because the A is negative. So what do you think this is going to have, a max or min value? max. And what's our maximum value going to be?
3.
4. So our maximum value is going to be 4. Now we need to find our domain. So going left to right, what's our domain going to be? So this graph, these arrows mean that it extends forever in this direction, forever in this direction.
Infinite?
Infinite, so all real numbers.
We just look for the sign.
Yes.
On the test, can we just put all real numbers instead of the infinite sign?
For the last example, it wasn't all real numbers because it started at -2 and then went on.
So we have to put the infinite.
So our range, starting at the bottom, our graph goes to -infinity. And where does it stop at? So we're going from the bottom up, and our graph stops here. So what did we say that value was? 4. So our range is going to be -infinity to 4.
Yeah, the domain.
Okay, and last example. We're going to write a quadratic function to model the graph. So what do we know our vertex is going to be? Our vertex is this point, right? So we're going to the left 1 and then down 3. So it'll be -1, -3. So if our vertex is h comma k, now we know what our h and k are going to be in our quadratic function. So what did we say the vertex form of the quadratic is? If you go back to slide 3.
A parentheses x minus h to in parentheses to the second plus k.
Perfect. So now we can just plug in the h and the k. So we have a times x minus h, which we have to flip the sign, so it becomes +1 squared, plus our k is negative, so we're going to do -3. So now we need to find this a value. Yes. How do you think we can find this a value? What was that? We need to find a value for x and y to plug into this equation. What value do you think we can use for x and y? We can plug in the numbers we have from the graph. So we have a point all the way up here, which is 1, 5. So we can plug in 1 for x and 5 for y. So we can plug in 5 is equal to a, because we still don't know what a is, times 1 we plug in for x plus 1 squared minus 3. So we're taking this equation and just plugging in x and y that we have from the graph. And now we just solve for a from this equation. So what do we do first to solve for a here? We can do the parentheses. So what's 1 plus 1? And what's 2 squared? So we have 4a minus 3 is equal to 5. Now what can we do? Add 3 to both sides. So we get 8 is equal to 4a. So a is 2. We divide 4 from both sides. And a is going to equal 2. So now we can take this a and plug it back into our equation. And we're going to get y is equal to 2x plus 1 squared minus 3. That's your answer for example 7. So that's everything for 4.1. So you guys have homework that's due tomorrow. And we'll go over the homework tomorrow in class.